Hello, this is the start of Chapter 8. Mr. Bogajski here. We are starting on similarity, so we're going to be talking about similar figures, triangles, quadrilaterals, pentagons, any type of polygon. Great start on the Chapter 7. This test will be a little more challenging, so really focus on setting up the correct portion, because if you do not set up the correct proportion in this chapter or unit, then we're going to have problems when it comes to assessing. Okay. Let's start out with a joke. What did the Italian man say to the witch doctor after he removed the curse? Hexagon. You get it? The hex is gone. All right, now move on to the lesson instead of lame jokes here. 8.2 similarity. Two figures are similar if and only if, right? If and only if the figures have the same shape but not necessarily the same size. So I'm thinking of a triangle. You think of a triangle. All right. Your triangle that you're thinking of, I know, has a 90-degree angle, a 30-degree angle, and a 60-degree angle. All right? My triangle has the same, but my triangle is this size. So are they congruent? No, they're not congruent, but they're going to be similar because they both have the same exact shape, but they're not exactly the same size. What do we notice? Similarity has this symbol right here. It's a squiggly right there. Okay, you'll notice it. It's part of the congruent part. So that's the similar part. They're just not also equal. When you look at it and you're able to set it up, certain sides match certain things. So like in everything else, the letters have to match up. So BC here would match with YM, so that side there, and so on, all the way around. Okay, the proportion is set up as a fraction. All right, it's a ratio. Moving down towards the examples, to show a similar polygon, by its definition, the ratios of the measures of the corresponding sides are equal, and the corresponding angles are congruent. So the angles need to be congruent to make the exact same shape, but then the sides are proportional to each other. They do not have to be the exact same. So using the idea of our statement up here, okay, so these are similar, so we need to match them up to make sure that they're the same. So the side 6 here had to match with the side YQ, that side there, so that's 6 over 9, which simplifies to 2/3. This side here had to match the 12, so that's 8 to 12, which reduces to 2/3. We have the 4 matching the 6, 2/3, and last but not least, the 10 to 15, which is 2/3. So we know all the sides are in a proportion. They're the same, they're equal. They all equal the idea of 2/3. So they're going to be similar. We're going to be talking about a reduction ratio and a dilation ratio. A reduction ratio is when something is less than 1. So the idea is less than 1. So in this case, 2/3 is a reduction ratio because that number is less than 1. The idea is being reduced is the ratio. The dilation or enlargement ratio. Dilation, I remember because if you've ever gone to the eye doctor and they put little drops in there and they're like, hey, I'm going to dilate your eye. What do? They put the drops in and boop, your eye expands, not the eyeball itself, but so they can see into the eye, and you have that. So an enlargement is greater than 1, which is 3 over 2. Note also the perimeters. So let's talk about the perimeters. Well, if I did the perimeter of ABCD, the perimeter is 28 when I add up all those numbers. When I do the perimeter of the other one, I get 42. So if I want the ratio of perimeters, 28 to 42, and I simplify that, what do I get? Wow, go figure. So the ratio of sides is the same as the ratio of perimeters. This is a fact I ask you to memorize, please. So the ratio of perimeters of two similar polygons is similar to the ratio of corresponding sides. All right, jumping in to the first example, we know that PMR, what does this mean? Similar to these two. Find all the missing sides and the missing angles. Well, let's do the missing angles first. So angle M matches with angle D. Oh, M is 90, so D is 90. So we got the measure of angle D equals 90. We got R. R matches with F, so that's 37. And then our last angle, what do we know? It's a triangle. How many degrees are in a triangle? 180. So then we're able to say that the missing angle is 180 minus what do we have here? The 90 and the 37 together. Or sorry, yeah. So subtract it, and what do we end up with? 53. So angle P is 53, angle Y is 53. Pretty simple so far this from last chapter. But we want to find our missing pieces. So X. So we have to figure out side DF. DF matches with which side? By MR. So the X matches with the MR, and the other one we have is the 15, the DY. That's going to match with the PM. So now we're able to set up our proportion, our ratio, and set them equal to each other. So we have 15 here is to 18 here. Go back to the same triangle as X, and X went with 24. How did you solve the proportion? Cross multiply, but I like to simplify first. So these are both divisible by 3. So really this becomes 5 and 6. Now I can cross multiply. Okay, and I get my answer that X equals 20. I want Y. Well, we still know the same ratio is 15 to 18, which reduces to 5 to 6. So I'm just going to start with the easy ratio. And then Y matched with the 30. So Y with the 30. If you don't flip-flop, I started here, and then I went back to it. It's just like setting up that slope formula. If you don't do that, what happens? You get it wrong. So, and then it's completely wrong. So stop making stuff up on your own and doing it correctly. Cross multiply, Y ends up equaling 25. Also a nice little note, besides knowing that the ratio size is the same thing as ratio perimeters, if the altitudes from M has a length of 14.4, then find the length of the corresponding altitude. Okay, well, what's nice about that is that the corresponding altitudes will match up to it. So what do we know? We know that the corresponding sides were what? The corresponding sides were, we said was 5 to 6, right? As the altitude in this one we don't know, but the altitude of this one, that's X, and the other altitude is the 14.4. So cross multiply, so 2 equals 6x. So x ends up equaling 12. So the ratio of the altitude from D is 12. All right, so now you could also put it there as the same as the ratio of altitudes. Okay, so they're all going to be similar, very simple. Good luck to you. Thanks for watching the video. Good night.